Hey, I'm neogoos by the way, and today I'm in Silicon Valley, and here everyone is obsessed with AI, slope, LLMs, ChatGPT, how you can improve development workflows and replace engineers. So I decided to talk about how I write code in assembly without syntax highlighting, debugger, CLI debugger basically, autocompletions, without like even basic LLM stuff because it's mostly useless. I hope you will enjoy this video because there is something I feel strongly that makes engineers productive more than just AI. So I'm going to show you how I add a feature into my React Server components implementation in assembly. And if you're interested how it works, please watch my previous video. It shows in details how React Server components work and the implementation details of this project. But basically, overall, you have this web page which looks amazingly beautiful, and I have this text which I can edit, and there is some weird markdown processing written in assembly which has some bold jokes. There's the bold jokes, sure, but I want to add a new feature here which allows me to add some links here, like, I don't know, this is not Rick rolling, sure thing, right? And there will be some google.com, I don't know, whatever. So you will see right now, it will basically throw it as a text with the properly escaped characters, everything. But what I want to do is to actually recrawl everything on every link they insert into my assembly parser or whatever. So this is an actual assembly that we're going to edit. And I know that sounds weird because I just told you that I didn't use syntax highlighting and auto-completions and all of these plugins, everything. But and that's actually true because, in fact, the real assembly, the real world assembly they're going to be paid for, yes, people are getting paid for writing assembly, will look something like that. It will be always some kind of inline assembly into your programming language with a lot of SIMD usages, and it will be much more bulky and much more weird. But the fact that you don't have access to all of this modern LSP features, auto-completion, syntax highlighting, everything, and you can still be productive writing this assembly, even more productive than, I don't know, modern AI slope can be. Okay, so I installed this assembly LSP, and I even didn't know that it existed because I just never need one. It makes actually like no sense because, like, look, every command in assembly is already a shortcut. Like, what kind of, like, you know, benefits I'm getting from this auto-completion? I still need to type everything. It's just like, what the type of requirements in here? It doesn't even give most of the information. Like, yeah, it might be useful, but I don't know. And even go to definition doesn't work normally. So like when I'm jumping here, it works. When I'm jumping here, it just doesn't. So I will just go and uninstall this assembly awesome LSP because I just don't need it. So let's add a new functionality. So you can see here we have this link format. So we need to like open some link, read this text in the brackets, then skip everything else and just continue as normal. So here I prepared some weird expression. It was complicated. I needed to make sure that all of the parentheses are correctly replaced, which is, you can see, you can do with your editor, but it was tricky. So let's start. So I have this escape string function, which is very simple. It receives x0 as an input buffer, x1 as an output buffer, where it writes the new processed markdown, and x2 is an input length, which it needs to maintain to be by the result of the function should be the output buffer length, right? So what we're gonna do, firstly, we're gonna add a new flag for the link is open, something like that. This is basically a true-false value stored on x9. Great. Now I will basically go down and I will create a new function to escape the link string. So here we will need to firstly check if the current character is an open bracket, like this, check open bracket. And usually autocomplete will actually serve a good purpose here. If you create a correct command on top of it, it just helps to skip the step of going to the ASCII table, which sometimes really useful. So now, if not, we will skip and we'll go to the not asterisk function, which is basically escaping all the characters one by one, which is okay. So now what we need to do is we need to actually increase the pointer by 1 because we skipped the bracket, and we need to set the flag to true. Let me do that for you. Move x9 will be 1 for true value. Great, so we now have a correct flag, and now a very important part for my workflow, I will basically load the start message to the register, and I use it through the snippets. I use them a lot, especially in assembly and actually in any programming language. So there is an RSC link start, if I'm not mistaken, and I'm loaded into X4. It's really helpful to have this set of instructions, which you really use a lot, because especially in assembly, it's just sometimes become really wordy and really bulky. But with assembly, with this kind of like snippets, usages for your personal needs is really, really, really helpful. So now we need to copy this buffer, which is constant buffer, into the output buffer. I will do this with my own function. Thank you, Copilot. I just typed that like 15 times. And this is a function which is basically going one by one, character by character, and copy the string. And notice that this is a not go to definition. It's my personal remapping, which automatically jumps to definition of the function. It's basically just doing a search by the current word and adding a column, which is really fun, and in assembly works impressively good. So I can go to definition to any function automatically using the same mapping as I did in a normal life, which is really nice, So now we call this function, and besides calling this function, we also need to increase the length accordingly. So I will load the length of the RSC link start length into x5, and I will add x2, x2, x5. Thank you, Copilot. The interesting part about Copilot that it can never guess what I need to do, but when I start doing that, I can, like, when I start typing it, it can be pretty helpful and can save some typing by moving the parts correctly. There is one important thing about assembly, that you don't usually write programs from scratch in assembly, right? Because that's the whole point of programming languages to exist, is to abstract over all these architecture specific details, right? You do them for improving the situation for certain functions. That's what you are getting paid for, right? So this is very important because you already started from something that you already have access to, that is generated by your compiler, and then you are working over it. So that's actually the reason LLMs are pretty much useless, because they don't reason about the code, and they don't have actually a big data set to investigate how assembly works. But for sure, when I do my things that I'm known for, a little bit viral for, like React server components in assembly, watch this video. For sure, it makes a lot of sense to just start from what assembly gives you and just generate some assembly boilerplate that is not really fun to write. So now, besides of that, I need to exit this function and go enter the loopback. So at this point, we basically insert the new link tag start at this point, and now we're going character by character, one by one here, like until we find this pattern, basically closing bracket and opening the parenthesis, right? Okay, great. Let's now create a function that will actually escape the link end and will insert the the closing tag. Great. So here, first of all, we need to check if the current character is the closing parenthesis. It will be 0x5d. If not, we will basically go to not asterisk. And now we need to do the same double checking as I do for double asterisk. I will basically type it here as well. And I need to check if the next thing is basically an opening parenthesis. In this case, we are checking that the current character and the next character are following this pattern. So in this case, what we're going to do, once we reach this part, we need to skip everything until we hit the next parenthesis. Let me do this with my utility that I already have. So I have this skip until. It's a little function that basically does entirely the same thing. It just goes one by one unless it's find the end of the buffer or it finds the character on the W6, right? So let me move W6. I'll move here the 0x28. No, it will be closing parenthesis and it will be 29. So I will basically increase it to 29 using vim command for sure. And I will call the skip until function, which is my function basically right here. Now we are like basically skipping the whole buffer, maintaining correctly the widths, and now we're in this position. So what we're gonna do right now, we do again this little const string assembly macro, which is do the RC link end. It will load it to x4, and I will do same thing. I will do bl copy string, right? Which is same thing we did for inserting the start of the tag. Mostly over. So what we're gonna do right now, we need now to also maintain the width, which is gonna be mob x5 into RC link and len, which is the length of the static binary we have in the binary already. So now we need to maintain the length. So what we're gonna do is we're gonna store the length of the buffer into x5. I will move here the RC link and len, and then I will increase the x2, which is an output length, store it to x2, increase x2 by x5. So I will add the length of the resulting tag to the output length, so we know how much bytes we need to read to the socket. Great, basically that's it. Let's go to the loop, and I think that's it. We should check the feature and how it works. So what I'm gonna do is I basically use splits, because usually assembly code is very, very narrow comparison. It doesn't have most of the like nesting, even though you can do some nesting, but I usually prefer put terminal here so I can do something like that. I can do the curl and I can just run my assembly. But first I need for sure to run the assembly itself. Let me do this. Now it works. Now let's try it out. And what we can see is we cannot see anything because we forgot to exchange the escape in the loop. We forgot to call the actual escape link start. We're gonna replace it with escape link start, and I will apply it here as well. So now whenever we are not facing the asterisk, we firstly check for links. So now we need to rerun assembly, and we will face some kind of issue here, which you can see that it seems to be not maintaining the correct length here. The curl doesn't allow binary searches, but you know what allows? Browser. So we can check, and you can see that we have 2 more characters here, which is weird. It shouldn't actually happen, which means that we're likely not maintaining the length correctly. So let's debug it. So first of all, let's find a point for a breakpoint. And unfortunately, I can't use a real breakpoint here because everything that's like breakpoints are doing in any language that you are using, they are basically saying that whenever we run the debugger or touch it, please modify the source of the program and insert some kind of instruction like this into this position. We can do it as well, but I think it's funny to do this in a low-level way. This instruction will basically throw the system exception, which will be then caught by your debugger, and then you can do something with your registers. So now I need to restart my program, basically rebuild it first. I will run it through LLDB, so I will say LLDB run the server binary executable. Now I will run it, and I will basically send a request. So you can see that we are stopped at the line 108, which is our breakpoint. And what we can do here is we can read all of the information that we want. So the length is x2, so I will basically do read x2, format D, which is format as a decimal, and it's 134. Great. What we can do right now, we can go next, but if you do this manually and not through the debugger, you will not be able to go next unless you will manually write this nonsense. So let me find this. Let me find this register write. Yes, exactly. So in order to unblock the execution, you need to write something into a specific register. So now we are like, it's just a problem of doing this manual instruction in assembly. Debugger doesn't know when it needs to write this to unblock the next execution. So now you can see that we are on this step, and now let's go one more. So we are now here, and what we're gonna do is we're gonna again read the x to the format D, and you can see that it is 250 minus 134. So let's do basically simple math. It is 116, which doesn't sound right. It sounds more information than it should be because I just calculated it. Okay, so here is the problem. This guy, our ceiling start, is basically 114 characters long, but we are writing out 116 characters, meaning that we are overflowing the buffer and some unnecessary characters from the program execution, from the text part of assembly is getting written into our output buffer, which is unparsable by curl, and this is obviously an error. What happened here is, like, I wouldn't spend your time debugging actually. The problem is that we forgot that the BL copy string is ending at null terminator, which meaning that we have to escape the null termination logic, and we also need to subtract the actual bracket from the output buffer, because output buffer length equals to the input buffer, and input buffer includes this bracket that we don't need to. So what we need to do instead of this one, we need to go and subtract from x2, write it into x2, and subtract this 3, right? So we basically do this. No, we subtract 2. Now we need to do same thing for the AND, because now we need to do the AND part. But here you can see that we escaped 2 characters, so we need to subtract 3 elements, null terminator and 2 characters. Now let's try to rerun it. So yeah, I'll do the assembly stuff. And it works. Okay. I actually needed to fix a few mistakes because I forgot to call this escape link end function. There was an issue with wrong hex code for the opening bracket, which is strange because I think it came from Copilot, but whatever. So now we can see that it works. And now when we reload the page, you can see whenever I type into my content, I can type something like, I can probably even type something like this, and it will just work within the link function. So my assembly parser is actually much more capable of a general markdown parsers. And when you click here, you also get into the recrawl situationship. Basically, that's it. That's how kind of general assembly. It's not that real assembly implementation looks like, but generally any assembly, you need to just make sure that you understand what is the point of working with different registers and different commands looks like, and then you are basically crushing it like boom, 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 boom. And one little detail that I forgot to mention is actually marks, because I so much love marks with assembly. I have marks for every important part of my app, like text section, data section, the actual request loop, the escape logic, and I always jump into them. This is really important because this is how assembly is structured. It's basically labels and marks where you jump between, and really killer feature in Vim. If you have an uppercase mark like this, when you are going to some other file, you can go to the uppercase mark from anywhere from your project. It's a killer feature and it's super useful. And generally saying, like, structuring assembly with a lot of breaks helps a lot, not only in mental parsing of the code, but also like when you navigate through it, these little blocks are meaningful. So like every navigation is really, really important. Thank you for watching this video. It's important for me that you watched till this point. I hope it was enjoyable. If you like what I do, you know how to let me know, right? GitHub sponsorship. Sure thing. Yeah. Follow. Bye.